Hello. So I'm here and honored to introduce our keynote speaker for the day, Dr. Rob Davies, whose resume boasts a breadth and depth of knowledge and talent across fields such as physics, ecology, meteorology, and the arts. He is currently professor of professional practice at Utah State University and has graced hundreds of stages just like this one to talk about his work on global change, complex systems, and human vibrancy. As a trained physicist, he's adept at synthesizing the interactions between physical and social sciences and the interconnectedness of us and our human systems, as well as the Earth systems that make our life possible. And so here to do that today for us is none other than Dr. Rob Davies.
Right, well, thank you so much. I want to just take a moment to acknowledge what it takes to put together an event like this. I've listened to a number of the presentations. I was riveted by a really powerful panel right after lunch. Colleen, Big Wind, Jacelyn and Phyllis, just stunning and exactly the right mix of information that's coming. You've gotten a lot of information today. Much of it is very detailed. Dr. Schumann talking about the regional climate impacts and sorry, I'm blanking, our other scientist that spoke this morning. Dr. Red Deer, did I get that right? So what I do, as Claire just mentioned, is kind of actually not what I was trained to do as a scientist. What we're trained to do as scientists typically is reductionist science, to drill down into very specific things in very detailed ways. But and we've gone a long way with that kind of process, right? Reductionist science takes you to something like this. But what it doesn't take you to is understanding something like the human brain, consciousness, or the Earth's climate system, complex systems. That requires synthesis of lots of different scientific fields, a huge spectrum of scientific fields. But if you're going to understand something like climate change, not simply the climate system, or on a broader scale, still global change, you have to not only include the hard sciences, physics, chemistry, biology, sociology, geology, but what I call the harder sciences, the social sciences, right? And so that's what I spend my time doing, is trying to synthesize this huge realm of study from the standpoint of understanding how we humans are impacting the critical Earth systems that envelop us, and understanding the sources of those impacts down to the system level and down to the mindset level. So what I'm going to do over the next 45 minutes or an hour or so is try to give you a narrative. This is not my scientific work. I'm presenting you a synthesis of a huge number of scientists. But it is sort of my telling of the story and my understanding of it, of where we're at, and it's trying to take a systems perspective. And so we're going to talk about climate change for sure. But climate change, it turns out, is one piece of the puzzle, a very acute piece, and which you all are focusing on very specifically. But as we all get ready to take these big steps, lots of effort, lots of resources into addressing climate change, we want to make sure we're taking those steps in ways that do not exacerbate other problems. We now inhabit a fully interconnected suite of ecological and social crises. One of our panelists, Phyllis, just after lunch, used the term, she said it's not climate change, it's climate emergency. And she's exactly right. And I'll come back to that word emergency a little bit later in a precise definition. So as we get ready to take these big steps, we want to do so in ways that synergistically help the rest of the challenges that we face and don't exacerbate those challenges that we face. We need to see the holistic picture as we go about our own work, working on individual pieces of that picture. So let's see how we do here. I also want to introduce this notion radical. Phyllis also called herself a radical. Oftentimes that term is used pejoratively, but of course it means extreme. And there is such a thing as rational radicalism. There are times that call for extreme response, and I think we're going to find we're there. So I'll tell you that the story that we're going to go through is not entirely pleasant. I think you all suspected that. We need to know that. We need to take that in. So what I'm going to do is talk about climate change for sure. But I think most of you understand the basic story of climate change. We'll review it briefly. What often we don't understand about climate change still is the scale of the risks that we're facing, the scale of the urgency, and the scale of the response that is required. And what you've been, to meet that challenge, to mitigate those risks. And what you've been hearing about all day today are absolutely fantastic efforts. I want you to keep in mind as we go forward with this story that there is so much happening right now. And as we move forward to meeting these challenges, there will be thresholds in social systems, just like there are thresholds in climate systems. Complex systems have thresholds that can work against you, but in social systems, those thresholds can also work for you. And it can seem like things just aren't moving. And I often use the example of an iceberg. You know, these things, they calve off the glaciers and they float in the ocean, sometimes for years and years, but oftentimes the smaller ones for months, and it seems like nothing's changing. They're just sitting there. And then one day they flip. They just flip. Because so much has been happening just beneath the waterline. Lots of changes. And social systems work the same way. If you're not paying attention on whatever it is the social issue you're interested in, it can seem like nothing's happening. But in fact, just beneath the waterline, often there are many, many people working to flip the system. Marriage equality is a great example recently here in the United States, where if you weren't paying attention, it seemed like nothing was changing, and nothing was changing. And then one state made a move, and then one state made a move, and then in 2 or 3 years, it just flipped. But of course, the people who were working on it have been working on it and working on it for decades, and you don't know when you cross that threshold, so you just keep working. So keep that in mind. So much is happening. And our job right now is to keep our noses to the grindstone and just keep pushing. We won't know when we cross the thresholds, so we're just going to keep pushing until the flip happens. All right, so the scale of the risks and the scale of the response. I also want to talk, whoops. Let me see if I can do, Let me see if I've got it here. I also want to talk about the context in which climate change is unfolding. And again, that's this interconnected suite of ecological and social crises. And then finally, because you're going to be in such a good mood by the time I get there, I want to spend just a little bit of time talking about a mindset that I think is valuable in moving us forward, that helps us get up in the morning and work on these things. So let's get started. The notion of climate change, here we go. You know the basic story. Wow, sorry. We are creating emissions in our society, principally from the burning of fossil fuels, of greenhouse gases, but also from large-scale land use changes. The most important of those greenhouse gases is carbon dioxide. We burn them and we emit them in billions of tons. That's our unit. Those emissions build up in the atmosphere in concentrations, parts per million. That's how many carbon dioxide molecules for every million other molecules. Greenhouse gases, because of their molecular structure, prevent energy that is leaving the Earth in the form of light, infrared light, trap it and convert it into thermal energy, heat, in the planetary system. And that's why these gases, and in particular carbon dioxide, are so important. Here's a graph of carbon dioxide levels in the atmosphere for the last 1,000 years on your left. Actually, it looked like this for about the last 10,000 years since we emerged from the last glacial period, at about 280 parts per million there on the left. At the start of the Industrial Revolution, at the end of the 18th century, we started to burn fossil fuels in volume, and it starts to go up. And I want you to look at the far right-hand side there, the middle of the 20th century, when it really starts to scream up to where we are today. There's our parts per million. 280 parts per million is where it has been naturally, and now we're at 410, actually 420 parts per million as of this morning. So that's what's happening. We're burning the fossil fuels. It's changing the atmospheric chemistry. It's a greenhouse gas, and we are warming the planet from the end of the 19th century to the middle of the 20th to today. As the different places went from the cooler blues to the warmer reds, they're warming up. This is not a map of temperature, but temperature change. Those dark red areas in the north, the Arctic did not get suddenly warmer than the equator, but the Arctic is warming up faster, quite a bit faster. So you can see that the temperature change is not uniform, but every place on the planet is warming, and if you average it all up, we've warmed the planet about 1.2 now degrees Celsius over the last century, most of that in the last 40 years. And if you're metrically challenged, I understand, you can always convert a temperature change from Celsius to Fahrenheit by roughly doubling it. So that's about a 2-degree Fahrenheit temperature global average rise. Now, it doesn't seem like a lot, but it's a rate of warming that's now about 50 times faster than the rate of warming the Earth experienced when we came out of the last ice age. This is not natural, this is us, and we know that for sure. Now, the thing is, if you were just change the temperature, that has itself plenty of impacts to us. Think of extended heat waves, for example. But it's a complex system, and in complex systems, everything's connected. So when you change the temperature, you change everything else. You change everything about the cryosphere there on the left, the frozen bits on the planet, continental ice sheets like Greenland and Antarctica, frozen sea ice, this is the Arctic Ocean, tundra, glaciers and mountain snowpack like we have here in the Intermountain West. Everything is melting. You change, my goodness, I'm sorry. I'm usually a little bit better at this. Can you take me back one more? There we go. You change weather patterns, which has to do with the exchange of energy in the Earth system. And that changes where it rains and where it doesn't and how intense. You change the water cycle. Warm the atmosphere, evaporation intensifies and dry areas get drier. But then you have more water in the atmosphere ready to come down when you get a storm, so precipitation events become more intense as well. You change internal climate cycles. For example, the La Nina, El Nino climate cycle we're all familiar with out here, which involves exchanges of energy between the ocean and the atmosphere. You change everything about the biosphere, the living bits on the planet, where things can live and where they can't, where they can thrive, when they go dormant. We heard some data on that earlier here in the Intermountain West, alpine systems being very rapidly affected. You change ocean chemistry, atmospheric chemistry, soil chemistry, freshwater chemistry, everything about our environment changes, and this then is what we call climate change. Anthropogenic, human-caused global warming is driving disruption of the entire planetary climate system. And I'll use that term disruption from now on rather than change because it's happening so quickly that natural systems and human systems are not able to keep up. Okay, so here's what we know about climate change. Slide, please. Earth is warming because of us, disrupting the entire planetary climate system. And the fourth thing I want to spend a little more time on is with extreme risks for humans. This is where we get into this notion of scale. So what do we mean by extreme risks for humans? And this is knowledge. What do we mean by knowledge in science is consistent with many independent lines of evidence, inconsistent with no lines of evidence. We know this as well as we know anything from our scientific system of knowledge. So let's talk about scale of risk and then scale of response. Here's a projection under a high carbon scenario, which we are roughly tracking on right now, for temperature rise across North America through the end of this century. These are done by NASA, by the way. Under a high carbon scenario, a scenario we're currently tracking on, we're looking at something on the order of summertime temperatures across most of North America rising about 13 degrees Fahrenheit. The dark red in the far north there is 25 degrees Fahrenheit of warming across the Arctic. That is a fundamentally different planet than we live on today. It has nothing to do with the human ecosystem in which we evolved and to which we are very highly adapted. On the left is the same projection at the end of the century under a low carbon scenario, should we get religion right now. Slide, please, thank you. 4 degrees Fahrenheit, which is still quite a bit of additional warming. But these are very different scenarios. Side by side, they present a choice. We are currently choosing the scenario on the right, not the scenario on the left, which we could choose. From a scientific or technological standpoint, we have what we need. From a scientific or technological standpoint, we have what we need, and a resource standpoint to do the scenario on the left. There's one more important difference between these scenarios, and that is that if we follow the scenario on the left, that's pretty much where it ends. That's where we stabilize. If we follow the scenario on the right, that's where we are at the end of this century. That's called the next 8 decades, but it doesn't end there. It's in all likelihood almost certainly continues for another couple of centuries to not 3 or 4 degrees Celsius of warming, but 8 or 11 or 13 degrees Celsius of warming, global average, over several hundred years playing out. I'll come back to that notion in a bit. People who study these results refer to the scenario on the right as catastrophic, and they use that term quite technically, meaning unadaptable by human civilization. Unadaptable by human civilization. And the scenario on the left is dangerous, meaning requiring a lot of adaptation. So there's our current path. I'm going to give you a couple of more projections to get this sense of scale down. We're going to look at snowpack. We know this is very important to us in the West. Where I live in Utah, 90% of us, Utahns get 90% of their water from melting snowpack. And we know that we always have good snowpack in the mountains in the late spring when it's at its deepest and starts to melt and give us our water for the rest of the year, this large reservoir. What I'm going to show you is data for this region of the mountains where we all live. The dark blue is the higher elevations, the deeper snowpack. The white is the thinner snowpack. I'm going to show you data starting in 1950. So this is actually what snowpack has been like in the spring. And then we'll look at projections again under a high carbon scenario, which is what we're currently tracking on. So this is data, and we can see that, you know, some years are snowier than others. We all know this. But we always have significant snowpack. And of course, our society here in the West is built to that. But as we warm under a high carbon scenario and more of that precipitation falls as rain instead of snow, as we move to a rain-driven hydrology, the snowpack thins dramatically, and by the latter half of this century is essentially gone. This is not hard to understand. The temperature rises and the precipitation falls as rain rather than snow. And we are already seeing this. You already heard data to that effect this morning. Particularly in the low and mid elevations, snowpack is thinning dramatically for this reason. Okay, one more set of projections. This is soil moisture, which talks about both precipitation and temperature change. And you can find yourself in a kind of a perverse situation with soil moisture where you might even be in a region that starts to get more precipitation, which is the projection for where I live in northern Utah, and yet still ends up drier because the higher temperatures increase the evaporation so much. So this is the first one, a moderate carbon scenario, sort of kind of getting religion, but not really right away. As the areas on the map get browner, they're getting drier. As they get bluer, they're getting wetter. Slide, please. Thank you. So drawing significantly over most of North America, Central America through the middle of this century, but then leveling off towards the end of the century as we start to get a handle on our emissions. Now I'm going to show you the scenario we're on, which is a high carbon scenario. Again, these projections come to us from the Doherty Earth Institute at Columbia and NASA. High emissions, again, significant drying through the middle of the century, then dramatically enhanced by the end of the century. The colors certainly look dramatic. And again, if we're on this scenario, this is not where it ends. This is just where we end the simulation at the end of the century. And again, if we look at these two as choice, we're currently choosing the scenario on the right, which people who look at this think of food system analysts, social system analysts, defense analysts refer to as catastrophic, again meaning unadaptable. And the scenario on the left is dangerous, meaning requiring large adaptation. So we're not talking about killing off every human being. we are enormously adaptable creatures. We live in the craziest climates. But not killing off every last human being probably shouldn't be our bar for success. Human civilization, on the other hand, is very finely tuned to the environment that it has evolved in over the last 10,000 years, this very stable period of climate called the Holocene. To show you how susceptible human civilization is to relatively small changes in climate, let's connect these dots, which are population centers on coastlines of 1 million people or more. On our current trajectory, we expect approximately 2 meters of sea level rise in the next, by the end of the century. Again, that's not where it ends if we stay on this, but 2 meters by the end of the century, which displaces directly 200 million people and displaces another 600 million people annually through high tides and storm surges, which is why the United States Department of Defense has issued a dozen reports in the last 2 decades calling anthropogenic climate change the single largest security threat to the United States, because imagine what happens when you displace hundreds of millions of people forcibly. Look at what happened across Syria with 7 million people displaced internally, 1 million people leaving, along with displacements across North Africa due to climate change directly, 1 million or so people trying to migrate into Europe, and the enormous political disruption that that has caused. And now that's with 1 million or 2 people. And now imagine multiplying that by factors of 10 or 100. This is just the data. And so when we talk about this being a catastrophic occurrence, that's what we mean, if it continues on the path that we're on. So it's these kinds of projections that lead scientists like Lonnie Thompson to make these kinds of statements. And some of you may not be able to read that. Virtually all climatologists are now convinced global warming poses a clear and present danger to civilization. Kevin Anderson in the United Kingdom, slide please. A widespread view that a 4C future is incompatible with an organized global community. 4C future, he means 4 degrees Celsius of global average warming above pre-industrial temperatures, of which we have already warmed 1.2. He goes on, likely to go beyond adaptation, devastating to a majority of ecosystems, and a high probability, slide please, of not being stable. And I want to focus on this notion of not being stable for just a moment. We're all familiar with the Titanic. It's the perfect metaphor for all things catastrophic. So this is how complex systems behave. They're twitchy. Nonlinear is the technical term, but twitchy is a nicer term, I think. You disturb them a little, they're disrupted a little. You disturb them a little, they're disrupted a little. You disturb them a little too much, and they move to a very different state. Of course, the Titanic hits the iceberg, but it's not a direct hit. They kind of, scrape along the side. Watch the movie, it's pretty good. And they feel like they escaped, right? I mean, some champagne glasses tip over in first class. It doesn't seem like it's so bad, but the guy who built the boat is on the bridge, and he's looking at the lights to see where's the water coming in. And he looks at the captain and he says, "We got to get everybody off the boat." Captain says, "What do you mean? That didn't seem so bad." Let's look at us sitting here in this room with our nice lunch and a beautiful facility, amazing homes, cars. Doesn't seem so bad. But the guy who built the boat says, no, this boat can stay afloat with 4 compartments flooded, not 5. And he can see that they're flooding 5 compartments. They've crossed a threshold. They've crossed a tipping point. And pretty soon, the forces that are keeping the ship on the surface of the water are going to start pulling the ship to the bottom of the water. That's how you disturb it just a little too much, 1 compartment too many, and you end up in a very, very different state. And we know the climate system behaves this way. It is, in fact, the behavior of the last several million years, the glacial and interglacial cycles. One of the tipping points that the paleoclimate scientists tell us is carbon dioxide level in the atmosphere. The last time carbon dioxide levels were above 350 million parts per million for any significant amount of time, say a few centuries. This was an ice-free planet, and sea levels were several hundred feet higher. Now, That doesn't happen immediately, right? I mean, they're flooding 5 compartments, but the ship didn't immediately sink. It took a few hours. Watch the movie. But once they were flooding that 5th compartment, the story was written. Now, in the case of the climate system, there's uncertainty here. We don't know exactly what the tipping points are, and there's more than just one. There's a whole suite of them. And the real worry among scientists is that we're very close to thresholds, and that once you collapse one threshold, you collapse another, you collapse another. So from a risk management standpoint, you don't want to get anywhere close to the edge, right? You know there's a drop-off ahead of you. There it is. Maybe it's 10 feet, maybe it's 100 feet. You can't see. Do you just keep walking, or do you stop well short of the 10 feet, just to be sure? So when the risks are this big and the uncertainties are there, the uncertainties are not our friend. The uncertainties are cause for more caution and more action, not less. Now, so there's our 5th compartment. We oftentimes talk about instabilities this way. Think of a marble in a dimple, and you disturb it a little bit, and the conditions around it tend to take it back to where it was. That's a conditionally stable system. But if you disturb it just a little too much, and it crosses that shoulder, that threshold, then all of a sudden the conditions that used to be pulling it back to where it was are now accelerating it away from where it was. And that's how we know the climate system has behaved for the last several million years. And once you cross those thresholds, the chances of getting back to the state you were in become much, much smaller, essentially impossible, certainly on any kind of a human time scale. So here's the last glacial, interglacial period. We were in that deep blue dimple. We popped up out of that deep blue dimple into our interglacial dimple 10,000 years ago. We've moved forward in time now to where we are here into this little no man's land, and we're wobbling around here. And are we going to drop into a new state by crossing thresholds, or can we get ourselves back into our nice, stable Holocene dimple? So hopefully looking at this graph, it becomes clear, there we go, that when we talk about the new normal, the intensified precipitation, the giant wildfires, the huge heat waves, et cetera, et cetera, et cetera, et cetera, we're nowhere close to the new normal. And we don't want to find out what the new normal is like. We need to get ourselves back into that stable Holocene dimple. And again, the good news is, the science says that's probably possible. From a knowledge, from a technological, from a resource standpoint, we know what to do. Okay, so what do we do? Whoops, could you go back one, thank you. From a physics standpoint, the highest level physics equation in this risk management problem is very simple. More carbon is more risk. So if you can identify a danger line and say we don't want to go beyond this because if we do, we start crossing thresholds, probably multiple thresholds, then you can calculate how much more carbon do we think we can put in the atmosphere and stay below that threshold. The threshold, the danger line that's been identified is 1.5 degrees Celsius. Used to be 2 degrees, but the impacts were building up bigger for the amount of change that we've had than were expected, so we lower the threshold, about 1.5 degrees Celsius, of which we've warmed 1.2. So here's our budget for 1.5 degrees Celsius. As of January of this year, about 280 billion tons. You don't have to remember that number. What you want to remember is this. This is how fast we're going to burn through that budget this decade. It's a very easy calculation. The next 10 years are the most important any of us will ever live through. The next 5 years are the most important of that. We can't win this game in the next 10 years, but we can lose it. We cannot win this game in the next 10 years, but we can lose it. Certainly from a risk management perspective, that is absolutely how we must proceed. Here's that carbon budget relative to the known fossil fuel reserves, carbon, coal, oil, natural gas, that we are currently exploiting. This isn't stuff that we haven't found yet. This is stuff that we've found and are actually extracting from. The physics tells us that we can only burn about 5% of the reserves we've already discovered. This isn't left or right, conservative, progressive. This is just physics. So that's the scale of the risk. What's the scale of the response if we are to meet this risk and mitigate it? These are carbon emissions. There are different units, so if you've seen other graphs with different numbers, don't worry about it. In the units I'm working in, 20 billion tons in 1990 were our emissions, 40 billion tons last year, and it only goes up. It only goes up. It only goes up. If we are to meet this risk, we have to peak now and we have to decline. And as long as this line is not zero, as long as this line is not zero, the temperature goes up and the climate changes. Call this a rational, radical decarbonization of our economy. We know how to do it, scientifically, technologically. Here's the crux. This is entirely a cultural challenge at this point. We do not know how to get ourselves to do it yet. And there are all kinds of reasons for that. And so addressing those reasons is addressing these problems. Misinformation, disinformation, alternate epistemologies, alternate facts, they all play a huge role in why we cannot get ourselves to do it. There are other factors as well. Now, here's where we're headed in the next 10 years. That's the pink. Here's where our current international climate agreements take us in terms of emissions, and this is where we need to be. Slide, please. Slide, please. Slide, please. Thank you. The shaded region underneath the curve, for the math nerds in the class, we just integrated. That's our budget. We need to peak now. If we don't peak now, if we peak next year, that means we burn more, slide please, carbon up front, slide please, and we have to make it up on the back end, slide please. It gets harder and harder every year. If we'd started in 1990 when we needed to do this, it would have been almost trivial to get to where we need to be. Now it gets exponentially harder every single year. We wait. But if we are to do this, here's what it looks like. We have to cut our emissions in half every single decade until we're down to zero. What that means is a 7% annual decline, 7% annual decline globally. But there's a catch, because of course there is. There is a huge inequity in who is responsible for the problem. 10% of the world's population is responsible for 50% of our emissions. If this top 10% of the world's emitters cut their personal carbon footprints to the average European, who have better lifestyle outcomes than we do, that would cut a third out of our budget right away. The low-hanging fruit, so to speak, to mix metaphors, is at the top. That's where the most can happen right away, is when the high carbon emitters, the very highest, cut their emissions just to the average European, which is about half that of the average American. 20% of the world's population is responsible for 80% of the world's emissions. That includes all of us in this room. It's the developed world that has not only the responsibility to do it, but the ability to do it. We're where the problem resides. Asking Bangladeshis and sub-Saharan Africans to cut their carbon footprints doesn't take us where we need to go pragmatically, and certainly makes no sense from any kind of social equity point of view. They're just trying to turn the lights on. The top 1% of the carbon emitters in the United States have a footprint 2,500 times bigger than the bottom 1% of the world. It would take 27 times the world population at the low end of the footprints to equal the top 1% in this country. Slide, please. Thank you. Okay. Now, so that means that the 7% annual global decrease needs to be closer to 15% in the developed world. Annual. Again, that's just the physics. This is the scale of the task that's in front of us, and you're asking yourself, that seems impossible, what can I do? And you're saying, how can I cut my personal footprint? I'll tell you how. Top 3 things: how we move ourselves, how we feed ourselves, how we heat and cool ourselves. For most of us in this room, it's fairly easy for us to cut our footprint 15% this year. Can you drive 15% less, fly 15% less? Can you eat 15% less industrial animal products? Industrial animal agriculture is responsible for 80% of agriculture's emissions. That's pretty easy for all of us to do. But then we have to do it again next year. And then we have to do it again next year. And it gets harder, and it gets harder, and it gets harder. Why does it get harder? Because the systems that we are embedded in fight us. And so while we are now at the point where it is necessary for us to be cutting our emissions, each of us, 15% a year, to give ourselves a little bit of extra breathing room to get the systems turned around. And if we do that, then the systems start to help us. It becomes easier to eat with a lower carbon footprint, to move with a lower carbon footprint, to live with a lower carbon footprint. But that doesn't happen until the systems get changed. So this isn't a question of personal response versus systems. We have to do both. We have to do both. We're so late in the game now. Peak now, 15% annual reductions, applicable at any level, from the household to the national. Slide, please. Thank you. Slide, please. Now, any sensible speaker would stop at this point. But I'm going to keep going. If you don't see how we can possibly do this, you're not alone. There's this great quote from Eisenhower, which I put up here, who knew something about big problems. Paraphrased just slightly, he said, "If a problem is too big to be solved, make it bigger." What he meant by that is you're probably not seeing all the pieces of the puzzle if you're not finding your way through to a solution. So we're going to make it bigger. I don't want you to try to look at these graphs in detail. I apologize for the visual assault. Just look at the shapes of the graph. Exponential growth on the right, skyrocketing starting in roughly the middle of the 20th century. These are impacts to different pieces of the Earth system. Let's take a look at them. This is atmospheric chemistry. Slide, please. One more. Atmospheric chemistry, these are greenhouse gases. Look at the middle of the 20th century, 1950, where it just starts to scream up. Next slide. Ozone depletion, surface temperature, ocean acidification. Slide, please. Marine fish capture, impacts to the biosphere, shrimp, the same thing. Nitrogen to coastal zones coming from agriculture, creating enormous dead zones in the waterways. Slide, please. All of those big screaming up graphs in the middle of the 20th century. These are our impacts to the Earth system. This is not just climate change. The documentation to this is extraordinary. I'm just going to throw up a couple of names of, these are massive synthesis reports that bring together tens of thousands of scientific studies. The data is very clear. What I just showed you is happening. Let me give you an example with the living systems. Ten years ago, humans had wiped out 60% of the world's living creatures in just 40 years. A new report came out last year. In the last 50 years, we've wiped out 70% of the world's living creatures. These are populations. In the last 50 years, humans have wiped out 70% of the world's living creatures. Along the way, the ecologists tell us we have increased the extinction rate by a factor of between 100 and 1,000 above the background extinction rate. This is not from climate change. It is from habitat destruction, extraction, and pollution. Elephants down 70%, lions, big cats down 70%, seabirds down 70%, large fish down 90%, sharks down 95% in just the last 4 to 5 decades. Over a 3-year period, 2015 to 2017, the marine ecologists tell us we lost 20% of the world's coral reefs. If we continue to 2 degrees Celsius, this is climate change, the marine biologists tell us we will lose all of the world's coral reefs. This is a foundational piece of the marine ecosystem, home to 25% of the ocean species, providing livelihood and food for 1 billion people on the planet. At the base of the terrestrial system, insects across Europe, over the last 3 decades, down 3/4. Across the Caribbean, down 90 to 95% in just 4 decades. We are absolutely decimating the living systems on this planet, and almost none of what I just showed you is climate change. 15%, the ecologists tell us, of this impact is from climate change. Now, that'll change as climate change accelerates, but up until now, this is mostly not climate change. It's hyper-extraction, hyper-consumption, hyper-pollution, massive habitat destruction. So fix climate change tomorrow, what I just showed you doesn't fundamentally change. Now, why is this happening? Let's look at what's happening with human systems. Again, just look at the shapes of the graphs. Population, really starting to scream out, middle of the 20th century. Gross domestic product, think of that as a proxy for energy and material throughput of the system, screaming up. Since 1990, since we knew climate change was an existential threat, we have put more carbon into the atmosphere than in all of human history before 1990. Exponential growth. All of these, you can just see the shapes of the graph. Think of paper production, by the way, proxy for, say, our impact on forests, land systems. International tourism, think of it as a proxy for globalism. How global are we now as opposed to regional or local? These are the symptoms. The underlying pathology is on the left. Get there. This appeared in a scientific article in one of the most prestigious scientific journals in the world about a decade ago. And if you think that sounds bad, you're paying attention. You're taking it in properly. Why do we have these systems, this food system, this energy system, that are producing these results? Did we design these systems to have these results? Of course not. Underlying all of this is an economic system that demands growth. The food system we have emerges from the economic system we have. The food system isn't designed to produce healthy, affordable food. The food system is designed to produce profit. Farmers don't grow food, they grow commodities. I don't know any farmers who feed themselves. Can't feed yourself with a commodity. The underlying economic system requires growth. Again, this is not a political statement or an ideological statement. It is simply an objective fact. A growth-based system. We know that politicians, policymakers, economists of all stripes all want economic growth. From Joe Biden to Donald Trump and Barack Obama, from Milton Friedman to Paul Krugman, they all want economic growth. Let's look at economic. Economic growth means growth in economic activity, which is tightly tied to energy and material throughput. I colored in a few pixels there. Can you go back? See if you can go back. Hold down the shift key and hit the back arrow. See if that works. This is important enough, I want to go back. Okay, one more. No, sorry, go forward. Stop. Sorry about that. I've colored in a few black pixels here. If I colored in the same number of black pixels every second, just keep doing the same amount, it would take 10.5 hours to fill up that screen. I did the math. But that's arithmetic growth. Add the same amount every certain amount of time period. But if we do exponential growth, which is to grow a certain fraction every time period, it's a different story. So let's do that. And the fraction we're going to grow is 100%. We're going to double every second. Instead of, here we go. Go ahead. 1, 2, 3. See it up there in the corner? 6, 7. 15 seconds to fill up that screen. Now, if instead of 100% per second, I had grown those number of pixels 3% per year, which is what the world's economists and policymakers tell us we need to grow the economy to thrive, 3% per year, it would take about 23 years to double. Each doubling time would be 23 years instead of 1 second. Grow anything at 3% per year, it'll double every 23 years. So, it would have taken 300 years to fill up the first half of that screen. Let's say that that's our resource base. That's our planet. And we're like, oh man, we have been growing the economy like gangbusters, 3% per year for 300 years, and wow, we still got half the planet left. Awesome. How much time to use up the other half? 23 years. Now, the economists dismiss this as a worry. They say we can decouple economic growth from materials. The Stone Age did not end because we ran out of stones. We have, and that is true, we can decouple ourselves from specific resources. We decoupled ourselves from whale oil. We can and we will decouple ourselves from carbon. But you can't decouple yourself from all material resource, and in particular, there is one master resource that you can never, ever decouple yourself from, and that is energy. The physics on this is extremely basic. But let's grant the economists their wish. We'll find more resources. In fact, let's find 3 more planets worth of resources. There they are. Now, we're not going to do this. This will not happen. I'm just humoring the argument. We've used up one planet, 3% growth. How much time to use up the next planet? 20 more years. How much time to use up the next 2? 20 more years. We did the absolute fantastical impossible, unicorns and fairy dust, as they say, and it bought us a few decades. So here's the good news. You ready? You're ready for some good news. The systems that are creating this massive ecological impact are going away. They are massively unsustainable. By definition, anything that's unsustainable will end. The bad news is, right now, our plan is to simply crash out, which brings with it really unimaginable human suffering, not to mention the other creatures on the planet. Our current civilizational metabolism, extraction and excretion, requires 1.7 planets worth of resources. We are at 170% overshoot of our resource base. Now, you can spend more than you make for a while if you have a bank account. But eventually that bank account depletes and you crash out. And that's what we're in the process of doing. Now, what's the time frame? 3% growth. Our plan, on purpose, is to be over-consuming our resource base more than 3 planets in 21 years, or 2 decades, and by more than 6 planets in 4 decades. And the science of complex systems tells us that the chances we get to this level of overshoot are essentially 0. Pieces start falling off the system. So let's put a top-end lid at 4 decades, probably closer to 2 decades. We can already see rumblings of it in the planet today, in the economic system today. So the systems that are creating this massive ecological disruption are going away. Can't happen soon enough. But we need to replace them with something that works, that creates for us. We humans will be sustainable, but most sustainable states for us on this planet are not pleasant. We want the just and vibrant states. To do that requires intention and planning, and again, there's really good news here. We know how to do sustainable, vibrant food systems. We know how to do sustainable, vibrant economic systems, steady state systems that do not need to grow in order to thrive. Okay, now, just one more. That's our current. If everyone on the planet consumed like those of us in this room consume, we wouldn't be in 170% overshoot, we'd be at 500% overshoot. Again, the inequity is extreme. And so I want to make one more point here. The inequity is extreme. And so we've been, right. So if that's your response, I understand. I don't mean to make light of this, but you got to throw in some humor where you can. I want to give us one more piece of these systems that are producing these horrendous ecological outcomes are also producing some pretty horrendous social outcomes. I'm just going to give you a few stats. I think many of you probably know this. 3 billion people exist in some form of critical deprivation on the planet. 70 million are forcibly displaced from their homes currently. Environmental, civil strife, etc. 40 million people today exist in some form of modern slavery. That's more than has ever existed in a state of slavery. More people in the history of humanity. 24 people on the planet control as much wealth and resource as the poorest 4 billion. 2 Americans control as much wealth and resource as the poorest 200 million Americans. This hyper-net, we're not talking about, oh, that guy wrote a fabulous book and he made $1 million. Or she's an amazing actress or artist and or physician and they made $1 million. And I only make 100,000, that's okay. They can, you do something really great, maybe there should be a little reward in there, that's fine. We're not talking about that kind of, so we're not using the word equality, equity, fairness. I don't know anyone who can do anything that would deserve that kind of, right? And it's hugely destabilizing. It's the same systems producing these social outcomes. It's the growth-based system that requires growth. It requires accumulation of wealth. It's built into the system dynamics, right? Okay. Okay, so let me conclude with this. I really don't mean to make... it's just so hard to take this in. How do you even look at this and say, where do you start? The good news is we have started. There are so many efforts out there. You don't have to reinvent the wheel to be a part of the solution. You have to plug yourself into something that's happening. So let's talk about a mindset to do that. There are a couple of aspects of this. The first is we have the scientific knowledge that we need. And interestingly, the scientific knowledge that has led to understanding where we live in the universe, the physics that goes into this. We've only acquired that knowledge in just the last few hundred years, the modern scientific method. From a scientific knowledge standpoint, we have everything we need. But along the way, over the course of the last, let's call it 500 years, with the rise of colonialism and capitalism and the scientific system, we've also forgotten quite a few things. We've lost. So we've gained a few hundred years of scientific knowledge about where we live and lost tens of thousands of years of indigenous knowledge about how to live. We have an economic system that gives rise to these other systems that produces these impacts. That economic system itself has arisen from a mindset. And our indigenous panel earlier today with Big Wind and Colleen and Jacelyn and Phyllis did such a beautiful job of moving between these two worlds of indigenous knowledge and scientific knowledge. They can quote the data, they can quote megawatts and gigawatts and gigatons and blah, 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 but they can also talk about understanding how to live as a part of a living system. Much of the world understood this prior to roughly 500 years ago. In the world of Western philosophy, it's the difference between where we are now, which is dualism, humans on top, separate from nature, to where we were before and where many indigenous cultures are still, what the Western philosophers call animism, understanding that we're just all part of a living system. The economic system we have has risen from a dualist mindset. And we must move back to a more animistic, holistic, natural mindset. There is no question. If you want new systems, you've got to have a new mindset to give rise to those systems. And again, the good news is here. We know what those systems need to look like, at least the major structures of them. There's a little bit more to this mindset, though, I think, on a practical level, for all of us getting up in the morning and not just moving forward in a daze or a state of depression. We have to stay mobilized. We have to stay engaged. We have to stay joyful about this. But how do you do that based on what I just showed you? I don't have the specific answer for everybody, but I can tell you what many of my colleagues who do this kind of work, and that includes many of you in this audience, I know that, come to, and where I've certainly come to, and what speaks to me, and what gets me up out of the morning, every morning, almost every morning, ready to go, as opposed to just deflated. So the first thing is, we recognize that this is an emergency, as Phyllis told us earlier today. Let's use that term very specifically. Emergency is a situation that requires immediate response to prevent catastrophic outcome. That is where we are. And the reason that that's a helpful mindset, helpful to keep in mind, is because when you have a mindset of an emergency, different things look different. So let's talk first about radical versus rational, and using the term radical in its pejorative sense. Let's define radical. Well, let's say what's not radical. Slide, please. Knowing about a crisis and responding is not radical. Slide. Institutions and people, slide, who know and respond are not radical. They are rational. What is radical? Slide, please, thank you. Knowing and not responding. That's insane. And so, slide please, the real challenge at the moment, in my view, in the climate discussion is not trying to move the immovable. That 8% or 11% of Americans who just refuse to ever accept that these challenges are real. I often get accused of singing to the choir. You're the choir. There's an old saying, why do you sing to the choir? Or preaching to the choir. Why do you preach to the choir? To get them to sing. This is not a question of moving the immovable. This is a question of activating the unactivated. So the single best thing we can do about that is talk about these issues to anyone who will listen in as constructive and meaningful and compassionate way as we can. But we can't be not talking about it. This is radical. 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 Not radical. Knowing about the problem and naming it, even if it's extreme, is not radical. We're in an emergency. Not radical. Jacelyn mentioned her work with the global youth movement, which is stunning. October 2019, 7 million people around the planet, spurred by the global youth movement, went on strike. This is not radical, this is rational. Direct action activism is the friction in the system that absolutely has to be there. The people doing it have my enormous respect for me. In particular, I'll mention the water protectors and the Standing Rock movements and Jacelyn's evolution of that. I'm a fellow South Dakotan, Jacelyn, if you're still here. So thank you so much for that work. Recognizing it's an emergency, and we're almost done here, I promise, changes the notion of viable and necessary. In an emergency, the concept of viable is irrelevant. Our guiding star in an emergency is not what's viable, it's what's necessary. And when we say viable, we usually mean politically viable, right? So let me give you a quick exercise. Go back. Forward. One more. There. Stop there. Anybody think this is politically viable? Should we ban the production and sale of new automobiles, internal combustion engine, period? Viable? We did it. We did this. December 1941. Congress passed legislation, the president signed it, said, Ford, GM, you are not making cars anymore. You're not selling cars anymore. You're making tanks, airplanes, munitions, trucks, jeeps, everything we need to meet the emergency. Unthinkable on December 6, 1941 was done by January 6, 1942. In an emergency, our guiding, and it was possible to do. And there were roadmaps on the shelf to do it before the emergency hit. And the good news is we have the roadmaps we need. We just need to implement them. I see a lot of faces in this room that are going to know what I'm going to talk about here. Ground all flights now, like right now. Tell them to land, everybody gets off, find your own way home. You can never fly again. Politically viable? You guys know, you guys might not. We did it. September 11th, 2001. For those of you who were like functioning adults on September 11th, 2001, can you even imagine prior to that anything like the TSA currently existing? You just walked up to the gate, anything you wanted in your bag. Done in an emergency. And that's what an emergency mindset gets us, what's necessary. And viable is just another step. The guiding star is what's necessary. So just flash through these if you would. Keep going, keep going. Keep going. We have to keep the fossils in the ground. If they get pulled out, they will get burned, period. That's what is necessary. Keep it in the ground. It's an emergency. We have to do that. If it gets pulled out, it will get burned. We want a sustainable and a just and a vibrant presence on the planet. This is our guiding star. Finally, this is in fact the end. There's an ongoing discussion in this world of this work that we're all trying to do of hope and despair. And I'm not here to offer hope. And I'm also not here to offer despair. It's the wrong framework in an emergency. You don't hope you get out of a burning house, you just get out or die trying. You don't sit in that burning room and try to figure out what's every step to get me out of this house. The only thing you figure out is what's the next step. And what's the next step. And what's the next step. Very brief historical interlude. This guy, most of you recognize, pretty complicated figure politically, socially, sort of historically. But in World War II, the summer of 1940, the United States is far from involved yet. The Germans have just run across Europe. The British Expeditionary Force, 350,000 soldiers, their entire military is trapped on Dunkirk. Europe has been overrun in a period of days. Invasion of Great Britain is imminent. Look at a map sometime. It was, in the hope-despair framework, hopeless. Chamberlain resigns. They hand the whole mess to Churchill, who'd been warning for years that this was coming. And in the hope-despair framework, it's hopeless. And he gets on the radio, and this is this, famous speech. Well, there's many, but this is one of them. And we shall fight them on the beaches, and we shall fight them in the streets, and we shall fight them in the air, and we shall fight them on the landing grounds and in the hills, and we shall never surrender. We shall never surrender. Watch the movie. Those are not the words of a man in despair. And in the hope-despair framework, there was no other place to be. Those are words of resolve. Absolute, utter resolve. It's not about identifying the last 10 steps to the top of the mountain. Sorry. I do this, and you can imagine I don't really get invited to parties anymore. So Our job is not to envision every step to the top of the mountain, certainly not the last 10 steps. Our job is to figure out what are the next 10 steps. And there are so many next 10 steps. And our job is not to take every one of them either. Don't try to do everything. You'll end up frustrated, exhausted, just eating steaks with the heat cranked that you got from carryout, double bagged in plastic. You don't have to do everything. There is a huge community of people working on this worldwide. That's the power of community. You don't have to do everything. The corollary to that is you have to do something. You have to pick something that interests you, that you can be joyful about and excited about working on. It can be global, it can be local, and so many people here, and the presentations that were here earlier, are about these very detailed local work that has to be done. Stuff that where you think your talents and your interests apply. Whether you're a farmer or a chef or a banker or an architect or a Knowles instructor or a violinist. What you want to plug yourself into that you're interested in, food, energy, economy, social justice. If you're working on social justice and you understand how it's connected to the rest of this, you're working on climate, you're working on ecological collapse, you're working on all of those things. If you're working on climate, you're working on social justice. So no one can tell you what that's going to be. That's your homework assignment. Figure out what that's going to be for you if you haven't already. I think many in this room already have. Final thought. It can be overwhelming to think of how much we've lost. We're going to lose a lot more. Sorry. But there's so much that can still be saved. That's where we are, and you're sitting in a room full of people who want to help. So thank you all.